In this video, I'll be discussing how you go about locating frontal systems and plotting the fronts within. Okay, so the first thing that you want to do is you have to remember is you always start with the low pressure center. So what we want to do with this low pressure center is we want to drag it to where the low pressure center is. Now, what things that you look for? Number one, you're going to look for cloud cover. And so as you can see in here, because the weather station model is indicating that it is 100% cloud cover, we know that it's somewhere in this area. The next thing I want to look at is I want to say, okay, I'm going to look for the lowest pressures, which of course 079, 060, you can see that those are very low pressures. And then you want to say, okay, now I'm going to also look for counterclockwise rotation. And that's because around a low pressure center, you have counterclockwise rotation. So I'm going to be looking at the wind vanes here. And those are the primary things that I look at. Well, if you look right there through the state of Missouri, you'll start to notice that you have this counterclockwise rotation. So what I'm going to do is I'm going to actually go ahead and put the low pressure center right in that area. Okay. So that's the first step that you want to do. The next thing then that you want to do is you want to do the frontal systems, and I always start with the cold front because that to me is always the easiest. So as you can see here, I'm going to drag that over. Now please realize that it's always going to hinge right there at the L. And the reason it does that is because, first of all, that's how I have it set up, because this is going to be the open wave mid-latitude cyclone. So I'm going to go ahead and make it kind of simple because this is just an introductory course. Okay, so now what you can see is you notice how I can rotate it around and I'll have to move it around and such. So let's just move it out of the way here for a sec. And what you want to look at is, since I know that it hinges right in that area and that continental polar air mass, because I'm looking at the month of April, is coming from the north, one of the things I always focus on is temperature differences. So as you can see, you've got some 40s, some 63s, and so now automatically I start to know that that frontal system is right in this area. Now, other things that you're going to notice is that you're going to say, all right, I see some of these things, so I'm going to go ahead and move it around a little bit. And I'm going to put that frontal system right through there. And the reason I'm doing that is because notice that that thunderstorm right through there, thunderstorms tend to occur right along that actual cold front. Okay, so that's what I'm going to focus on there. And you notice that everything that is behind the cold front is cooler temperatures, the 40s that you can see through here. And everything in front of the cold front is actually warmer temperatures because it's in a different air mass. In this case, the maritime tropical or maritime or continental tropical air mass. Okay, so now the next thing I want to do is I want to plot my warm front. And of course I do know that it's going to hinge right in this area again, so they always kind of hinge like that. So I'm going to move it around here so that it's kind of facing the direction that I want it to face. Okay. Now, much like the cold front, the thing that I focus on here is I tend to focus on wind directions, but at the same time I tend to also focus on temperature more with the warm front. Because you don't have a severe weather along warm fronts, you don't get the pressure differences, so you tend not to have extreme differences in winds and stuff like that, but you will notice that you have a distinction between temperatures. So you can see here's the 40s again, here's some 60s, so automatically I know that this warm front is kind of going up in this direction. Now all I got to do is kind of rotate it and make it fit there a little bit better so that these warm fronts, how they move like that. And notice that I have them both hinging right at the L. That is the typical for the open wave mid-latitude cyclone. So what you've done is you've actually plotted your frontal system just like that. Okay. Now, one last thing you want to look at, and not in every scenario, but in some scenarios, you may have what is called a dry line. And we know that the dry line is a boundary between a continental tropical and a maritime tropical air mass. So both of these are warm, so the temperatures aren't going to be drastically different. But the primary thing, if you look at a continental tropical as compared to a maritime tropical, the number one thing you're going to focus on is you're going to focus on relative humidity, or the dew point depression is really what you focus on. That's the dew point depression is the difference between the temperature and the dew point. Well, whenever you start to see this type of scenario where you're like, oh, 78 and 65, that's really not significant. So, but there is significant, there's 13 degrees of change here, 78 and 71, 78 and 74, but then you notice this 81 and 8. That is a dead giveaway that you have a dry line. And now the thing is you notice that dry line, the reason I moved it over into this area is because you have the increased cloud cover, and that dry line is actually providing lift. So what you've done there is you've gone ahead and you've actually plotted your actual frontal system there. And then what we can do is we can save this. You can save it as a PDF file instead of a PowerPoint, which makes it a lot easier for me for grading. And so you can just end up saving that thing, and that's how you go about plotting your frontal systems onto a weather map.